Oh, hi everyone. Mathieu Canal, working as Danfoss as a heat pump solution director. I've been working for Danfoss for more than 9 years, and previously I was in the compressor division, industrial division. Today I'm going to talk about the solution that have been developing from the commercial heat pump segment. To clarify any misunderstanding, and Danfoss is not a manufacturer of heat pump, but we are such a broad portfolio that we are working on different type of solution with our portfolio for the heat pump market. So when it comes to heat pump, I guess you're all aware that heat pump plays a kind of crucial role to decarbonize the heating process. We're going to find a heat pump, of course, in already the case on single-family homes today. And today we're going to focus my presentation much more on the commercial heat pump solution, both for the space comfort, for multi-family buildings, for example, and also for the production of hot water, for the hot water production. What I'm going to not cover during this presentation that have been covered previously by one of my colleagues is what's going to be related to process heating solution that we've been developing lately. So when it comes to commercial heat pump right now, first thing that we've been looking at is the different type of refrigerants that we are considering for this market. So first of all, the residential, that is not really the purpose of this presentation. Today the split R32, in the future is going to be potentially propane up to certain capacity, and then you need to deal with the refrigerant charge limit, and in case the PFAS are still alive due to the age, then potentially you may use 4540 for this split application. But we do think that most likely most of those popular applications in south of Europe will switch to monoblock. So today in monoblock for single family homes, it's already there, it's propane. What we've been working recently is to develop our solution for light commercial heat pump. So today we've been working a lot from the segment from 20 to 200 kilowatts, and we have next phase that's going to be above the 20 kilowatts up to the megawatt with propane. So our main development in this field has really been to first of all to maximize the efficiency and to reduce as much as possible the refrigerant charge with our solution, both on the compressor and the heat exchanger side, in order to remain below the 5 kilogram of propane per circuit. So that we think that you can build a heat pump up to 200 kilowatt with 2 circuits, let's say, with this type of solution below 5 kilowatt. Water to water, especially in the residential market, of course, there's a certain part that will be propane. So here we have developed some solution with our portfolio that is able to reach 5 to 6 kilowatt heating capacities with 150 grams. Above this, then risk assessment needs to be done by the OEM, or in case the HFO are still alive, blends could be there, such as 4540C. And the last thing I want to briefly talk about is about what's above, I would say, 70 degrees water temperature for hot water production. We do see quite a good traction, especially in North America, for the CO2 heat pump. In Europe, we've been working on developing a dual solution with HFO, with 1234ZE, and isobutane in this case for solution above 100 degrees, below 100 degrees, and above 100 degrees. We are focusing on development of solution with other type of refrigerants such as 1233ZD or butane. So I'm going to skip those slides in order to be fast. So when it comes to the development of our portfolio for what concerns propane, so Danfoss is a manufacturer of compressors, plate heat exchanger, expansion valve, and also lots of different parts of related to the electronics. Right now, when it comes to compressors, what we've been working on, I don't know where is the stuff. What we've been working on is to develop a range of scroll compressors that is able to reach for the OEM capacity up to 200 kilowatts. So we have two range, one which is a variable speed one, what we call the VZN, with different models. We released this year 4 models, and there is a last one that is currently under development, the 220cc, comes with the drive. And we also released a range of fixed speed compressors for this market. called the DSN, so 3 different models, the 10, the 12, and the 15 ton. And right now we are currently, so those developments, they are kind of over, and we are currently developing large capacity propane compressors in order to target let's say the commercial market above 200 kilowatt. So that's going to be what we call the DSN large. In the meantime, we've been working on developing solution related to our microplate heat exchanger. So we revamped completely our range of plate heat exchanger in order to optimize the heat exchanger with propane. So meaning for us, we had to redesign the plate and also to minimize as much as possible the old volume in order to allow the OEM to be able to design units that can go up to 150, 200 kilowatt with 5 kilogram of refrigerant. So lots of development has been spent on the development of first heat exchanger, the H62, that covers a range from 20 to 50 kilowatt, and the 118 that is currently able to go up to 180 kilowatt. What you don't see in the picture is the current development that we are doing with dual circuit. All of our expansion valves, they were already qualified. And the last thing that we've been working on is on all the electronic portfolio associated with this market, meaning we are coming with a new controller for this market that we call AllSmart. And within this controller, we developed the complete application software related to heat pumps. So it means that we have already a heat pump software that runs, embedding all the different libraries of our compressors, of the control of the superheat of our expansion valve, the control of the gas detector, etc. So this is something that we have already embedded within and tested within our application development center in Denmark. On top of this, what's new in this market is that we are coming with a new gas detector for propane, the DSTG290, and a new pressure transmitter, a bit more, I would say, designed to cost for the heat pump application. So if I go to the next slide, I'm going to highlight 3 main topics, 3 main products. I'm going to highlight mainly what we did on the control side with the launch of the AllSmart, the compressor, and the range of plate heat exchanger for the propane application. So when it comes to the launch of propane, we wanted to come with a new platform of hardware, of control, and that has been currently showcased and launched at Mostra Convenio this year, and this is highlighted currently on our booth in the 7 hall. So this is AllSmart, which is a new modular control platform. So in fact, you have different modules that you can expand according to the need of IOs that you need in your application. It's included connectivity, embedded Ethernet. Like I said, enhanced IOs, you can have multiple modules in order to meet the needs of the application. And we are coming with a complete new software in order to allow the OEM to program their own heat pump software program directly on the hardware. One thing that we've been working on is, like I just previously mentioned, is that we've been developing a full environment of application, meaning envelope control of our Vision compressor, the control of the inverter. All of our superheat is already embedded in our software, and that has been tested in our laboratory in Denmark, where we can test complete units. So the launch of the AllSmart comes with the application. So we are providing a full scope of application from the residential to the commercial application. Basically, what's inside the software is we can do either air-to-water or water-to-water application. What's inside the thermodynamic, we can do single circuit, double circuit. We can do variable speed technology or fixed speed technology, so multi-scroll technology. Of course, the defrost, and the last part, the superheat control. So everything is already, I would say, ready to use. Of course, the OEM can start from there and customize it according to their need, or they can use it as is. So today we've been focusing our development on the scroll, but we also have a kind of similar software for turbocore application in case of heat pump, for example. And we are currently also working on developing. This one is for propane, but we also have ongoing development for CO2 heat pump. So that's part on the control. When it comes to the compressor, today we've been releasing this year, like I said, 4 models: the 86, the 104, the 140, and the 175. So those are variable speed compressors. The compressor is already pre-qualified with a drive. So the drive embeds some safety features, such as the oil boost. It doesn't include the map protection, for example, but all what concerns the reliability related, for example, for overheat motor, this is embedded in the drive. The compressor has been designed primarily for heating application, so we are able with these compressors to do something like minus 15 evaporating up to 82 degrees condensing. So it means roughly minus 5 ambient, and we are still able to produce water at 80 degrees. And we go in SST up to 25 degrees. Everything is already available. Like I said, supply temperature, we can go up to 80. Today, we are pushing only to have this compressor running in single mode. We don't want to do hybrid. So hybrid for us means that you have a single compressors in manifold with a fixed speed one. We want to keep it single to make it easy for the OEM and also to ensure high reliability of the solution. In terms of speed, we are going from 30 to 140 RPS, and we have the big rover that is coming next year. That's going to be the 220 cc that will be available. So everything is available. You can contact us if needed. And the last point that I wanted to highlight related to the development that we did on the commercial heat pump for propane is the development of our portfolio of plate heat exchanger. So we are coming with different options according to the need of the OEM when it comes to cost, performance, or compactness, for example, or refrigerant charge. So we have a full range of single wall heat exchanger. So the ones that are really for residential is the H30, but when we go between residential and light commercial, the H62 can cover up to 50 kilowatts. And the H118 can go up to 180 kilowatts. So those are standard single wall plate heat exchanger. There are some low charge versions that are available, especially in the residential size. And today we are, like I said previously, we are working to develop the dual circuit version in order to target capacities that will go up to 300 kilowatts in the near future. When it comes to double wall, we don't plan to develop any double wall for commercial application. We're going to keep the double wall only for the residential one. So it means that the solution to mitigate the potential issue of a breakage of a condenser on the heat pump should be mitigated with a deaerator, for example. So it should be mitigated on the water line. And the last thing is that we also developed evaporator, especially for water-to-water application, in order to minimize as much as possible the hold-up volume with the new H62 EZU that can cover up to 50 kilowatts. Still a question mark if we're going to do something there in the future for propane, for application that's going to go above 100 kilowatts. So that's a bit basically what we did those last few years at Danfoss for development of our portfolio for commercial heat pump with propane. Propane is really right refrigerant, I would say, especially in Europe for what concerns all comfort heating application. What we do see quite a lot right now, and that's going to be my next slide, is going to be about the solution related to CO2. We see more and more CO2 heat pump in Europe for sure. In large-scale CO2 heat pump, but also in the US, where we start to see more and more CO2 heat pump for hot water production. And basically, when it comes to CO2, as we see a lot, more and more CO2 within a heat pump context, we do think that, that's not we do think, the reality is that CO2 performs well according to certain conditions that needs to be met, right? And those conditions really rely on the water return temperature on the gas cooler side, and needs to be as low as possible in order to maximize the performance. Otherwise, the performance is quite lower versus other type of refrigerants, such as the subcritical one, propane, hydrobutane, or ZD. So like I said, CO2 is extremely sensitive to water return temperature. There is 2 to 3% loss per 1K water return temperature difference. And heat pump in a heat pump context, CO2 makes a lot of sense for domestic hot water production, or in a building where you have a huge load of domestic hot water versus the need of comfort, so that you are able to operate at least with a water heater temperature that is below 40 degrees. For sure, when you have a building that is only for underfloor heating, CO2 makes no sense. And for radiator, it starts to be already quite a challenge if the conditions are not met. So that's really where we are pushing. I would say our CO2 solution in heat pump context. Really hot water production could be also industrial cases. So in terms of portfolio, with the acquisition of Bosch, we have all Bosch version of our CO2 compressors up to the 6-cylinder. With a stronger motor for heat pump application, and right now we are also working on the development of the 8-cylinder that's going to be out potentially end of next year. In terms of gas cooler, we are coming with by the end of this year with a gas cooler primarily for supermarket, but this gas cooler can also be used in a heat pump context up to 100 kilowatt heating capacity, so still commercial. And we plan to have larger sizes for the future. And all of the rest of the range, meaning hot gas, high pressure valves, CCMT, ICMTS, etc. Those valves that have been developed for supermarkets, they are also fitting quite well CO2 heat pump application. When it comes to ejector, and this is mainly for large industrial application, we are currently developing a new industrial gas ejector that is currently displayed on our booth. So when it comes to CO2 heat pump, we are doing exactly the same journey than the rest of the portfolio. So we are starting with the controls, where we are developing audio libraries and the application software to run properly a CO2 heat pump. So this is on the shelves for water to water. We are to develop the libraries for air to water heat pump, which means basically handling the defrost, and that's going to be on the shelves for the different OEM. And for what concerns the compressors, what we've been working on a lot lately for CO2 application at Danfoss is to, as much as possible, we do think that CO2 can be used a lot for water-to-water application, especially in a heat recovery mode. And we tried as much as possible to operate in high evaporating temperature as possible. So the Bosch compressors, they are qualified up to 25 degrees. So what it means when you are producing water at 80 degrees, just such as in this case, and when you have a return temperature at 40, we are still able to operate, especially during summer, at a higher evaporating temperature, and then you are performing quite well because you are not limited to the 20 SST. You are operating at 25 SST, and this is giving quite a nice improvement in performance due to this ISST. So this is something that we focused a lot, like I said, in order to. So this is a special motor that has been developed by the Bosch team in order to target this segment and this application for heat pump. So basically, but this is super valid for water to water then, and that's basically this is what we've been doing in terms of journey at Danfoss for heat pump application in both in commercial. So space comfort, the full development of propane component, and when it comes to hot water production, we spend time and development related to CO2. So if you have any question, feel free to contact me, or I'm going to be at the booth. Thanks.